Hello, everyone, and welcome to Manufacturing the Future. The transportation industry is undergoing a revolution driven by technologies such as battery electric drive, autonomous driving, and enabling technologies such as AI and the Internet of Things. But not everything that moves operates on roads. Agriculture and construction are cornerstones of the economy, and that sector has enjoyed the same kind of technological revolution that's changing the automotive and aviation industries. In many cases, the demands are actually higher. Productivity, efficiency, safety, they're all important, and now environmental factors are entering the picture. Now, how is industry responding to this technological challenge? Joining me are Sarah Fueling, Senior Director of Construction at the Association of Equipment Manufacturers, and Ben Holter, Director of Automation Systems for Husco. Sarah holds bachelor's and master's degrees in civil engineering from the University of Wisconsin-Milwaukee, and Ben holds a bachelor's degree in mechanical engineering from the Milwaukee School of Engineering and a master of science degree from Northwestern University in predictive analytics. Sarah and Ben, welcome to the show, and I'm going to dive straight in because there's so much to talk about. Autonomous vehicles, self-driving, everyone's talking about it. It's the hottest technology in the automotive industry today, and multiple companies are working on it. The trucking industry, they're addressing labor shortages by adding sort of higher levels of technology to try and take the person out. Self-driving, it's been talked about with various levels of success. There's just a ton of tech that is suddenly being adopted from what used to be sort of the software realm, and we're jamming it into things that traditionally were thought of as mechanical systems down there. What about OTR equipment? Will that self-driving loader, grader, backhoe, is that going to change everything? Are we going to get rid of the operator? Basically, is someone from a beach in Cancun going to be digging that trench? How about it? Sarah, let's start with you.
I'll say it. That's all great points, Jim. But yeah, we're seeing a lot in the on-road space and development and technology. And like you said, how all these pieces come together. We've seen a little bit of it already in mining, right? Where those more controlled operations are happening and that autonomy space is a little more fluid. But from an off-road perspective, we're absolutely bridging that gap now between what is typically heavy equipment, right? And technology. Part of it is just where we've come as an industry, right? But it's also part of that labor shortage is also a piece of it, where we are able to use this technology to take what was a good operator and turn that person into a great operator. There are automated features, machine control, grade control, all of those things that are really helping our operators in the field do more and do it better. They're eliminating rework and reducing the need for additional grade checks. And that's all of those advancements that we've seen in GPS, GNSS technology, all kind of coming together. And we'll see where that takes us in the future. We definitely have a bright future ahead of us as we work through these things.
Sarah, you're an expert in civil engineering, and there's something I think that non-civil engineers have pondered, I certainly have, which is what defines accuracy and precision in your world compared to a world, for example, of machine tools or even 3D printing. I think there's sometimes a sense out there that, well, I work to tolerances of thousandths of an inch, and you're digging a tunnel, so close enough is good enough. Just how tough is it to do those tasks?
Yeah, we'll use something as simple as a grading operation, right? Tolerance is typically less than 1/10 of a foot. So that's 1.25 inches, which sounds pretty big when you're relating it to something that's talking millimeters, right? But that 1.25 inches really adds up. And again, we rely on our strong, experienced operators to get to that level of accuracy. But now when we combine that with the GPS and GNSS technology in grade control, we're able to bring that down to hundredths of feet. So we're talking 1/4 inches. And that in itself really kind of drives those efficiencies. You talked about that productivity, as well as it all ends up to $1 at the end of the day, right? So if we're going to take that 1.5 inches, 1.25 inches over a 12-foot lane, every mile, we're almost at 240 cubic yards of material. So now you're going to make that up in your pavement, you're looking at $35,000.
Yeah.
Not to addition the additional placement time, as well as the additional staff and work that requires. So that accuracy that you talked about really adds up when you're able to use something like a grade control that's going to get you within those several hundredths of a foot versus 1/10 of a foot. And now you're talking dozens of yards versus hundreds of yards.
Sarah, do you still measure efficiency the same way that you used to in this industry? Is it, I mean, there's used to be a sense of, I know what my operating costs per hour are. Basically, I've got a sense of how long it's going to take basically to sort of grade for that interstate. And I get a sense that time and cost overruns were fairly common. They still are. Is it tighter today?
Yeah, I think definitely a lot of our contractors are getting smart. They're using the technology to their advantage, right? And they're finding those nuances, those productivity gains, those efficiency gains, using some of the other tools, the software tools that are out there and available in the industry to really balance out and hammer out what those bid prices are, what that time is going to take, what that cost is going to take. And in their operations are finding ways to get it done better and faster, which adds up to a dollar amount at the end of the day.
Yeah, yeah. Ben, Sarah talked about the idea of this advanced technology actually making a better operator, or sort of a super operator, if you will, using sort of these devices. But equipment operators, they have specific tasks to perform in maneuvering vehicles, and they have to operate multiple controls. All of us who've tried the incredibly complex technique of, say, operating even a backhoe are concerned. But good operators have an intuitive feel for things like rock and soil conditions, traction and gradient, breakout force, weight. They can sort of feel these things intuitively. Will future automation systems control these multiple factors in the way that human operators do? I think do you have to put sensor systems in, and then intelligent systems that operate the same way that a really good operator does when he just has an intuitive sense of what the critical lean angle is of the machine, or what the breakout force is? Is it easy? Is it hard?
Great question. Talking about the operator, an operator, a person, is an amazing machine. It's really difficult to understand what's all going in our brain and how it operates. So trying to put all of that into a control system is even more difficult. Automotive is running the same problems. How does machine vision work? How do you tell if it's a person or if it's a rock, if you can hit it, if you can dig it, or if it's dangerous? All of those things happen in the operator's brain instantly, and we know if it's right or wrong. It's really difficult to program and really difficult to understand. So even breaking down just how to get back to that grade that Sarah talked about, she talked about a tenth of a foot accuracy. That tenth of a foot at the bucket tip, if we talk about a 20-ton style excavator that's on the side of the road, that tenth of a foot accuracy at the bucket tip equates back down to a 1 millimeter accuracy on the cylinder position. That 1 millimeter accuracy is talking about the hydraulic compliance, the cylinder compliance, the hose compliance, even the structure compliance. If any of those stretch more than 1 millimeter or compress more than 1 millimeter, now you're off by that 1/10 of a foot. So we think about, how does a person do that? That's amazing. Like, a person can control something that's that compliant to 1 millimeter. It's all about muscle memory. It's all about time in the seat and understanding how that works. We have amazing machine learning algorithms in our head that are constantly working that we don't even think about. And so bringing that back now to, how does a control system make that work? 1 millimeter on a cylinder, we're talking 1 milliamp on a control system to control a hydraulic control valve. That 1 milliamp is less than the parasitic of your phone charger sitting on the side of your bed right now. So we think about these numbers, and it just continues to drop orders of magnitude more and more tight, harder and harder to achieve. But an operator is doing that every day. And so the difficulty we have as hydraulic manufacturers, as OEMs, as construction companies, is, how do we make something that maybe takes 10 or 20 or 30 years for an operator to get good at? How do we make that good day one? Because nobody's going to go buy an automated machine that it works like a 2-year-old's driving it. Everybody wants to buy an automated machine that operates as good as their 40-year experienced veteran today, day one, because they've got the labor shortage. They want remote operation. They want all of these things that we have today with experienced operators. They want in a control system. And so with the convergence of technology, GPS getting better, sensors getting better, more rugged for our industry, dust, light, vibration, so much harsher in the construction industry. That convergence of technology making it possible is now putting the onus on us hydraulic manufacturers and other controls manufacturers to make this possible. We are now able to do it, and we now just have to prove that it's possible. And so really diving down into all the control systems, all the transfer functions of how each system needs to work and how tightly controlled each system needs to be is really the beginning of us making this work. And we're starting to see in these really complex machines like excavators, starting to see this become more and more of a thing. We talk about automation, not autonomy, because the first step towards autonomy is automation. We need to automate some bits, whether it's grade or whether it's e-fencing. You talked about how we make the operators better. How can we do that? Well, make it so that if they're tired or not thinking, that they can't swing into a road or they can't dig into a pipe, And so if we have that information in the site plan and we can program that into the machine, now we can make that happen. We can stop the operation of the excavator digging a pipe and having to move away everybody because there's a gas leak. But that all starts with electrohydraulics. A lot of machines don't even have electrohydraulics, and you can't even plug in a control system to make that happen. And so we're incrementally taking steps forward in our industry to make all of this possible. And it's really an exciting time in our industry because all of this is becoming very possible and starting to show in the end market.
Ben, you mentioned the really the brilliance of the human body and how amazing it is that we have those proprioceptors and that incredible feedback system that lets us operate with that sort of remarkable precision and touchdown. If you're going to duplicate that or enhance that with the systems you're developing at this point, what is your feedback system? What are you doing on the sensor side there? Is this radar, LiDAR? Is this force sensing? Is this something you can detect, for example, back at the hydraulic cylinder? Or is this something that you need to do perhaps at the bucket or the end effector end? I mean, how do you even start this process?
It's where do you start? Really, where you have to start is understanding that the operator today could look and see that grade has met where it was supposed to meet. The GPS may tell it, or a surveyor may put a stake in the ground and tell the operator where the bucket tip is versus where it's supposed to be. So the first thing we need is sensors. And those sensors have made huge strides in improvement in ruggedness and in accuracy. So now we're able to access satellites, access IMUs, inertial measurement systems on these machines to every 10 milliseconds or even faster in some cases, know where that bucket tip is and know where it is with relation to where it's supposed to be. So the first place we have to start is that. And that technology is finally becoming mature enough where it is rugged and we can rely on it day after day, 24 hours a day, and start using those systems. To get where we're understanding things like loads or soil conditions or even obstacles such as people walking around, we're still looking for advancements in sensors and reliability. If we add, let's say there's 10 functions on a machine. If we add 20 sensors, one for each extend and retract of a cylinder, right and left of a motor, now we've got 20 extra potential failure modes that could take down a system. Those extra potential failure modes could take down a machine, which could be on a path that's really important and could stop production of something for who knows how long, depending on how long it takes to get that machine back up and running or replace that sensor. So the more sensors we add, the more concerned the operator is going to be for uptime. And so we're always weighing what's the need of the sensor versus the value of the sensor versus what happens if the sensor goes wrong. So from a performance and accuracy of productivity and efficiency standpoint, and then on top of that, a functional safety standpoint, we're always trying to weigh how many sensors do we add versus what does it give us versus what could go wrong in that state. And it's different for every customer. It's different for every system. And we're still trying to figure out what's the best solution. And it's going to continue to change as technology continues to advance the robustness, the acceptance of sensors, and the ability and the cost of sensors to put all of those on.
There used to be, it's sort of anecdotally or given a thought that junior operators, less experienced operators are hard on equipment. And we know you could shock load hydraulic systems and create all sorts of problems back in the day when you were basically using, say, a fixed displacement, fixed pressure pumps, and basically with a blow off valve, and you're using an accumulator to try and damp some of those shock loads. And a lot of things can happen, unexpected things can happen. And so in some ways you could define a great operator as one that was not only efficient but also was easy on the machinery. We're looking at a world now where we may be bringing a lot more inexperienced people into the industry because of labor shortages at this point and getting them up to speed faster. Is this kind of control technology, this kind of sensor technology, does that work into that factor too? Can that paper over some of the inexperience of an operator, maybe even help them get better, do you think?
Yeah, it's a really exciting question because we're at a point right now where as electrohydraulics, as control systems on these large construction machines become more accepted, like they are today in the automotive industry, we're able to add more sensors and add more controls to like you said, help out these younger operators. But what that also does, which is really exciting from the hydraulic valve manufacturing design standpoint, Osco that I work for, is now we can start simplifying our hydraulic systems. The last 6 decades, we've continued to improve performance, improve efficiency, and improve controllability and safety by adding widgets, because we didn't have a software control system that we could modify or change controls. It was a physical system. And so the only way to make it better is to add complexity, add extra widgets to do the things that our customers are looking for. Now that we can put software into this mix, we can start decomplifying our hydraulics and making them simpler hydraulics, which means less failure points. But then we can give the same operation, the same functionality, productivity, efficiency that we're getting without all of those extra bits, all of those extra failure points. And then furthermore, we can modify how the valve feels depending on the operator. So we can put in a inexperienced operator mode that's maybe softer, more filtered, maybe lowered speeds. However, the end user, however the owner of the machine wants the operator to act, because in the end, if the operator is ruining the machine for the owner, they have to pay for it. And so we're able to do things depending on operator, depending on region, depending on what the machine's doing with the touch of a button, which has never been possible before, which is what's making this so exciting for us in and beyond just automation.
Sarah, in civil engineering in particular, big projects, we're seeing a revolution in the way some of these projects are designed and built now. We're looking at things like undersea tunnels, very, very deep construction, skyscrapers, tall construction that involve foundation work in areas that would previously be considered completely unsuitable. In fact, new materials, new hybrid materials, concretes. Not far from where we're talking about this, a new office tower is going up, and it's about 12 stories. It's made of wood, of laminated wood, which is something which I never thought I would see in my life, at all. Are new generations of machines going to be necessary in lockstep with this new pool of labor coming in to even build some of these projects? I mean, back in the day, if you bought a D9, it was expensive, and you kept it on the job for 30 years. You wore it out and you replaced it when you had to. Do you have to now go through a different equipment cycle now based on its capability rather than its life expectancy?
I don't know that it's necessarily a different life cycle, but there are those advancements to those machines. Let's take that D9 that you mentioned, right? You could have bought it 30 years ago, but all of our OEMs and our technology providers and our hydraulic manufacturers are now making a lot of aftermarket retrofits, right? That you can bring your machine along with this advance in technology and these new operations. Like you mentioned, there's different alternative materials, different construction methods, kind of changing how things are done, but it's not necessarily going to change your machine unless you need it to or want it to. So that's, again, the beauty of what of all our OEMs and our component suppliers are doing, is they're giving end users and these contractors the ability to build the machine that they need to best do their job, whatever it is, right? There's a lot of options out there, these technologies and a lot of these control points that Ben was referencing, that all plays into what those OEMs are putting out for their big machine. And then the contractor, the end user, can absolutely customize that. So obviously stuff that's coming off the line has these things integrated, right? There's a lot of integral technology, which is great and wonderful to see, especially when we know this younger generation coming into the industry, they're used to computers, they're used to touch screens. They know what widget means, right? If you go back to some of our more experienced operators, those that have been in the industry for a while, when you're now, instead of a couple controls, you've got a touch screen. This younger generation is going to be able to just naturally get in line with that, where I actually went up to the local here in Wisconsin, the Operators Union Training Center, and got to operate machine control, grade control system. And you're still on the controls and the levers, but I got to sit in the seat and touch what was like an iPad and determine which mode I wanted it on, right? To make it easier for me, a very, very inexperienced operator, to figure out how to use this technology to do what it was that they wanted us to accomplish that day. So I definitely do think there's great opportunity for equipment, both new and existing, to really align with where the future of construction is going.
Sarah, you mentioned specialty equipment, and that's a trend which we have noticed here at engineering.com. Where in the past, if you were doing pipeline work, for example, you used a basic track laying tractor chassis, and then you might have added a boom for example, something as simple as that. You might have added a grappler in place of a shovel. Relatively simple sort of aftermarket sort of add-ons now. We're seeing a whole generation of equipment now, which is incredibly specialized. Most recent one I saw was actually a pavement milling machinery. Unusual stuff that does very, very special jobs, highly specialized, and clearly not based as a modification of a simple existing chassis. Although clearly the underpinnings may come from a Deere or a Cat or one of the OEMs at this point. Is that the future? Are we going to see a world in which there are smaller OEMs that are making very specialized equipment for a very small market just to get that last bit of productivity?
Yeah, absolutely. I think what we've seen a lot of actually is a lot of it is contractor driven, where there are contractors who are very, very specialized and they do a repetitive type of a specialized work, and they have taken it on themselves to retrofit some sort of equipment or build their own attachment that does what 2 or 3 different attachments did previously. We are highlighting a lot of that. And you'll see in ConExpo, ConAg 2023, we've got a lot of those features highlighted from an OEM perspective, that you see these new solutions, right? They sound very simple. It's a common everyday problem, but it helps bring down the work, right, and the load, and really specialized solutions to account for all those things. Along with that, what Ben was mentioning and all those different sensors and all this hydraulic and where that's all moving, that's all going to be at IFPE as well. So within the industry itself, we are really highlighting some of those things, trying to draw attention to not only the industry, but to those smaller manufacturers, right? That really have a game changer, really have some stuff that's going to change the future of the industry, and give them an opportunity to share that on a wider scale.
And following up with Sarah there, talked about auxiliaries and attachments. I think agriculture has done a great job. You have one power plant, you've got the tractor, buy a ton of attachments and do what you need. We're starting to see that in our industry a lot more, especially at the supply side. Where auxiliary attachments, auxiliary sections used to be just an add-on that you just needed to do a certain flow rate. Now, auxiliaries are becoming some of the most deluxe systems that we're selling, the deluxe sections, because they have to have pressure control, flow control, a damping on them, zero back pressure for hammers, and we're putting a lot of the deluxeness in those to handle all of the different auxiliary requirements that are being driven by end users that have this new attachment or this new attachment that we never thought about before, to get more use, more productivity, more uptime of a machine that's on a site, rather than bringing in specialized machines for pipe laying. Now, like you said, you add an attachment to make it a pipe layer. And that's really exciting too, because then you talk about software and what you can do with software. Now you talk about different pressures, different flow rates, rather than somebody having to go out and change a relief valve setting or worry about blowing up their attachment because it wasn't rated for that pressure. We can do that at a touch of a button to the hydraulic valve to change that setting and say, oh, I've now got a hammer or a grapple or a brush cutter. And we can set that all automatically to, again, update productivity and also make it easier for new operators so they don't have to worry about remembering to change relief valve setting before they blow up that brush cutter. Again, more opportunities for us to meet the market needs with hydraulic improvements that we've been waiting for to come.
Sarah and Ben, do young engineering grads, students, perhaps the public at large, are they aware of how much technology is in this industry? I think there's a conception out there that, you know, a bulldozer is a bulldozer. It's been the same for half a century. I mean, you're talking about cutting edge technology here. Is there a perception that it's there? Sarah, how about you?
I was gonna say, I definitely think it's not as out there as we would like it to be. Where I think you're exactly right, Jim. It's you look at a piece of machinery and you're like, it's heavy machinery, it's dirty, like it's basic, it's rudimentary, right? And it is so not. So we are, I think, as an industry, trying to help change that narrative, right? Change that perception, tell that story to say, look at all this technology and all these different things that are within our industries. Like, for example, if we're talking about all this software, right, that goes into running these machines, somebody going to college right now thinking they want to be a software engineer isn't considering a career in construction, but they could be and they should be, right? None of these things are possible without all of that technology and those typically construction or manufacturing roles, right? We are really broadening and widening that net of what is our future workforce pipeline. So as an association, as AEM, that is part of our workforce initiative to help tell those stories, to tell some of this fun, exciting things that we're doing in this industry with technology to help draw the next generation and to change that perception.
Ben, your education could have led you to Silicon Valley.
Yeah.
And how much fun are you having in this industry? I mean, this industry is clearly a place where high tech lives.
It's so exciting. I mean, we just finished deployed and getting customer approval on a 10 function valve, and so you think about a 10 functions. I've got one power plant that's controlling the power to 10 functions. And you think about the control system and how you control that. You've got 10 degrees of freedom off one power plant, all at different pressures, all at different forces that an operator expects to work harmoniously. And you don't think about how hard that is because it's worked in the past hydromechanically. But when you put it into software and try and, again, make the hydromechanics a little bit more simple, it's a really complex situation. It's more than just a gas pedal and a steering wheel, not to detriment anything that the other industries are doing, but it's an amazing problem that's really exciting and really hard. It's all nonlinear. It's all Bernoulli's equations 10 times. And you think, well, hydraulics are going away. But then you think that bucket cylinder that's 20 feet out on a big excavator, that needs 100 kilowatts to work. Imagine putting a 100 kilowatt electric motor diesel engine at the bucket cylinder to make that a distributed electronic system. You need a motor to get that power out, and the power density of hydraulics are just so good, and the robustness of hydraulics that it's going to be around for a while. And so we're solving really exciting, hard problems in an industry that's being disrupted in an exciting way for us to solve global socioeconomic, geopolitical problems along the way. So it couldn't be more exciting. And yeah, love what AEM's doing to help make this initiative to get people into this industry, because hydraulics aren't the dirty, messy hydraulics you thought about 20 years ago. If you take a tour of our manufacturing plant, if you see us at FP, it's very clean. It's automated. Our valves are being manufactured in an automated way, similar to what automotive is doing and what their industry is driven. So it's new, it's exciting, it's clean, and it's really hard problems that are, again, I'll just keep saying it, exciting.
There's just so much to talk about. We could do this for hours. I hope we get a chance to do more of this. But just to sort of wrap this up or give a cap on this whole initial sort of shallow dive that we made into this topic down here. We're looking at a world now where the demographic challenges are real. This isn't a short-term blip where we just have to wait 5 years. We'll have another generation of skilled operators that will pop up out of the woodwork. At the same time, the demands in civil engineering, Sarah, as you're noting, are much higher. We've got to dig deeper. We've got to do it cheaper, faster, new materials, all sorts of new factors at the same time. Look forward, please, 10, 20, 30, 40 years from now, basically. Is this going to be the Jetsons? Are we going to have technology we don't even realize today? Or will this be something where this is recognizable, but much different? Sarah, let's start with you.
I think that's a very interesting question, Jim, because you can look at it a couple of different ways, right? Where, especially on the construction side, we're an industry typically very slow to change, right? We've done what we've done, and we've done it well for years. But if you look at where we've come in the last 20 years and where we could potentially go, I like to always compare it to music. Okay, so those of us that were born in the 80s, in my lifetime, from middle school through high school, I went from a cassette to a CD to an iPad to my phone in a 10-year window. Now extrapolate that and where the industry could be from here, right? I mean, we've got Tesla talking about being on Mars in 30 years, right? What are we going to be doing here? So I think absolutely there is the potential for 10 years from now, these advancements, and as that's proven, I think that's another thing that's I think Ben mentioned it earlier. it needs to work, and it needs to be a proven solution and a proven technology. And once the industry starts seeing that these things do work and they do the job well, I think at that point we'll absolutely see 10, 20 years from now, these things will extrapolate, tie that into these automated features that we've got, right? Everything we've talked about is automated. We're not quite to autonomy with any of these things. But this is step number one to get us to that potentially autonomous future, right? Pulling out some of those operators, pulling out some of the man hours on site, and being able to do this with the technology we have available. So I think absolutely, it's very exciting to see where this could go, and it could look very similar, but it also could look completely different. And that's for the industry to really help us drive towards that and realize what that shared future could be.
Ben, you'll be engineering that future. What do you think it'll look like?
Yeah, putting machines and digging footings in Mars will be interesting. But we'll figure out a solution to do it. So that's I think is what is cool about this industry, is that we need to be there to make sure that we're building houses, building roads, building infrastructure here, wherever it might be. Speaking 40 years out, and we're going to continue to be more productive with it and more safe with it. All the things we're doing are making people more safe, machines more safe, more productive, more efficient. And so the opportunities of where we can go in even 10 years are crazy to think about, because there is just so much opportunity. And with the convergence of all of the sensors and computing power and algorithms, really the opportunity is endless of what can our end users imagine is possible, and then we'll figure out a way to solve it. And that's what's exciting.
Sarah Fueling, Association of Equipment Manufacturers, Ben Holter, Husco, thanks for joining me on the show, and thank you for watching. See you next time.